In the first few weeks of July 2026, satellite instruments tracking a narrow strip of the equatorial Pacific Ocean, stretching from the coast of Peru out toward the international dateline, recorded something that climate scientists had not really seen happen this fast before. Sea surface temperatures in that strip, the region meteorologists call the Niño 3 4 zone, shot past 2 degrees Celsius above normal in a matter of weeks, which is the threshold that separates an ordinary El Nino from what gets called a super El Nino. And the pace of that jump is apparently what has people paying attention, because this region typically warms up gradually over many months, not in a sudden lurch during the middle of summer. So this is obviously kind of a big deal, and I guess to understand why, we first need a quick refresher on what El Nino actually is, in case you've only ever heard the name without really knowing the mechanics. Under normal conditions, trade winds blow steadily from east to west across the tropical Pacific, essentially piling up warm surface water near Indonesia and allowing cold, nutrient-rich water to well up along the coast of South America. El Nino happens when those trade winds weaken or even reverse, and that pile of warm water sloshes back eastward, spreading out across the central and eastern Pacific like a lid being lifted off a simmering pot. Once that warm water is sitting at the surface, it doesn't just sit there quietly, it starts pumping enormous amounts of heat and moisture into the atmosphere above it. And that reshapes rainfall and storm tracks basically everywhere on Earth, from droughts in Indonesia and the Amazon to flooding in the southern United States and East Africa. For decades, scientists measured the strength of these events using something called the Oceanic Niño Index, or ONI, which basically just compares the temperature in that Niño 3.4 box against a fixed 30-year historical average. But here's the problem, and it's a problem that's become increasingly hard to ignore. The entire tropical ocean has been warming because of human greenhouse gas emissions. So a fixed historical baseline from decades ago starts to look almost quaint. And events measured against it can appear artificially dramatic just because the whole ocean is warmer than it used to be. So climate agencies, including NOAA's Climate Prediction Center, have been shifting towards something called the Relative Oceanic Niño Index, or RONI, which subtracts out the average warming of the entire tropical belt before comparing it to that one specific region. In other words, RONI tries to isolate the actual El Nino signal from the background warming trend, which sounds like a pretty small technical tweak, but it turns out to matter enormously for how we should talk about records. And this is where the actual centerpiece of this story comes in, because on July 24th, 2026, Carbon Brief published an analysis by climate scientist Zeke Housefather that pulled together forecasts from 667 individual model runs, sourced from 14 different modelling groups, including the American CFS and NMME systems, Europe's C3S system, Canada's CANSIPS, and Japan's Syntex-F. And what these models are converging on, more or less unanimously, is kind of remarkable. Using the traditional Niño 3.4 index, the median forecast has this event peaking at 3.59 degrees Celsius, above normal sometime between July and December of 2026. And more than 91% of those model runs predict that this will end up as the strongest El Nino ever recorded, surpassing the previous record of 2.75 degrees set during the famous 2015-16 event. Now, obviously, the sensible next question is whether that number is inflated by the exact baseline problem we just talked about, the fact that the whole ocean is warmer now than it was in 1997 or even 2015. And so Housefather's analysis also ran the numbers through RONI, the adjusted index, to see if the record claim would survive. And it basically does, although it gets a bit more modest. Using RONI, the median forecast peak comes down to about 3.1 degrees Celsius. And the previous record on that adjusted scale was 2.69 degrees, set all the way back in the 1982-83 event, not 2015-16. Even after stripping out the background warming trend, 77% of the model runs still show this event breaking that older record. So essentially, however you slice the data, whether you use the raw numbers or the numbers adjusted for a warming planet, the single most likely outcome is that late 2026 delivers the strongest El Nino event in the modern observational record. So now we've got at least a couple of different ways to think about why this event is developing the way it is, and it's worth walking through them one at a time rather than just accepting the headline. First, there's the straightforward oceanic dynamics explanation. This year saw an unusually persistent and powerful burst of westerly winds across the Western Pacific in the spring, which is basically the trigger mechanism that kicks a big pile of subsurface warm water toward the surface and eastward. And the amount of built up heat sitting just below the surface going into this year was apparently already unusually large, sort of like a compressed spring that had extra energy stored up and ready to release. Second, there's the baseline explanation we've already touched on, which says that at least part of what looks like unprecedented intensity is simply the ocean running warmer everywhere all the time now. So events that would have looked moderate several decades ago now register as extreme. And third, there's a more cautious statistical explanation, which is that forecasts made in spring and early summer have a known and well-documented tendency to overshoot, a phenomenon researchers actually call the spring predictability barrier, where the ENSO system is intrinsically harder to forecast several months out during that particular season. And so some of what we're seeing in these June and July model runs could still soften by autumn. But here's where things get just a little bit more nuanced, because that skepticism doesn't actually undercut the story all that much this time. Forecasts made after the spring predictability barrier has passed are historically much more reliable, and this event has already blown past record onset speeds, even in observed data, not just model projections, with the Niño 3.4 index rocketing from 1.6 degrees in June to above 2 degrees within the first few weeks of July, which is apparently faster than any prior El Nino event developed at a comparable stage. So this isn't purely a model artifact sitting out in some hypothetical future. It's something that's already partly happened and been measured directly. At the same time, it's worth being honest that nobody can say with certainty exactly where the peak will land in November or December, and there's a meaningful range across those 667 model runs, not just one confident number. Some of the excitement in the headlines probably deserves this kind of tempering, but the underlying signal that this is shaping up to be an extraordinarily powerful event seems to be holding up under exactly the kind of scrutiny that should have broken it if it were mostly hype. And I guess the reason all of this matters beyond just Pacific Ocean trivia is what it does to global temperatures, both this year and maybe even more importantly, next year. The first half of 2026 already came in as the third warmest start to a year on record, behind only 2024 and 2025, and both May and June ended up as the second warmest versions of those months ever measured, with a brutal heat wave scorching Western Europe in late June that set national temperature records in France and the UK and was linked to thousands of heat-related deaths. Carbon Brief's own modelling now puts the odds that 2026 overtakes 2024 as the outright warmest year on record at around 35%. Which is basically double what it was back in April. And that entire jump in probability is almost completely explained by the El Nino forecast getting more aggressive month after month, not by observed temperatures actually running hotter. But as a matter of fact, the biggest story here might not even be 2026 at all. Because of how heat moves between the ocean and the atmosphere, there's typically a lag of a few months between when an El Nino event peaks and when its warming effect shows up most strongly in global average temperatures. We saw exactly this pattern play out after the 1997-98 event, again after 2015-16, and again after the more recent 2023-24 event. The year the El Nino actually develops tends to be warm, but it's the following year that ends up smashing records. And so if this event peaks around November or December of 2026, as expected, its biggest thermal punch lands squarely in 2027. Carbon Brief's projection puts 2027 at roughly 1.71 degrees Celsius above pre industrial levels, which would give it something like a 92% chance of becoming the new hottest year ever measured, and a 94% chance of coming in above the symbolic 1.5 degree threshold that's baked into the Paris Agreement, which is a strange thing to sit with, honestly, because it means the headline grabbing super El Nino everyone is watching unfold right now in the middle of 2026 is, in a sense, mostly a preview. The real consequence of this event, at least in terms of the number that ends up in the history books, probably doesn't even arrive until the year after next, quietly, once the ocean has finished handing its extra heat over to the atmosphere above it. And underneath all of that sits the bigger, genuinely open question that doesn't have a tidy answer yet. If the background ocean keeps warming decade after decade, and if these naturally occurring El Nino swings keep riding on top of that rising baseline, at what point does super, a word that used to describe maybe one or two events in an entire human lifetime, just become the ordinary shape of how the Pacific Ocean behaves?